Well, good morning. I apologize about the lateness of this particular assignment. I know it was supposed to be yesterday. However, I have an extra day in the semester, and as I am not opposed to using it, I'm going to. So this assignment is not due till Tuesday. The assignment that was due Friday is not due till tonight. And the assignment that was due last Thursday is actually due on last Friday, which means the test will now be on Thursday. So, without further ado, let's get started on this assignment. This is Lesson 3, Student Activity Sheet 7, Using Technology in the Unit Statistical Studies. So, let's get started. All right, now let's go back to where we were the day before. Suppose data were collected on 25 bags of spud potato chips. The weight to the nearest gram of the chips in each bag is listed below. So look at these 25 figures. What displays might be helpful in verifying the claim of the weight of 28.3 grams given on each bag? So let's go back to the lesson before. Which one? A histogram, a dot plot, maybe a box and whiskers or a box plot, what do you want to call it? Maybe even a line plot or a frequency chart. One thing we didn't get into is a stem and leaf. That might help, except that on a stem and leaf, this would only have one spot, and it's the 2s, and all the rest of the numbers would show. So anyway, what other values might assist in knowing more about the center shape spread and unusual features of this set of data? I think you can answer this pretty simple. The 5-number summary answers that last question really easy. It helps you understand the shape spread and unusual features, and to see it, a histogram might work, but that depends on the bin width you've chosen. The box plot does a great job of describing it, whether it's skewed or not. And a line plot or a dot plot, what do you want to call it? A dot plot. It shows every value in the whole data set. So that would definitely show exactly any kind of skewness or outliers that might exist in this data set. So, all right. So to better understand the data, let's organize the data by sequence. So what we've done is we've taken these values here, and we put them in sequence, in order, and we'll create a dot plot of all the data. As you can see in this data, you can see how all of it is pretty much, as far as the grams and potato chips, it's fairly well distributed. It's distributed regularly, okay? It's not spread out too much. And there's no outliers, and we described what an outlier is. Well, let's move on. Describe the distribution. Okay, roughly symmetric, centered about 25 to 26. Range is 5 grams from 23 to 28, from a low of 23 to 28, and there are no unusual features. All right, does it appear to support or contradict the manufacturer's claim of an average weight of 28.3 grams chips per bag? Well, if the average weight is 28.3, that's right here. Every value from every bag we actually measured is below it. So we don't have enough evidence, though. There's only 25 bags we actually measured. So it's not enough to declare the manufacturer's claim false, although we can speculate that another investigation or a more thorough investigation needs to be actually conducted. All right. Let's use the calculator to create a spreadsheet or spreadsheet software. We're going to use a calculator. And we're going to create a more formal display of this data. We're going to make a histogram, okay? Now, we're going to make it look almost like that. So I need to pull my little trusty calculator over here. And I have to go back to the values so that we can enter them, all right? Fortunately, oh, let me get rid of this. Sorry. Fortunately, I've already entered those values in here. So if I want to create a dot plot of the data like that, oh wait, let's get to the right screen. Let's try to create this histogram. Oh, I went backwards, sorry. So let's see what we can do. All right, get this up in the front. And these are the values, I've already entered them. If I want to make a histogram, I have to go in here, and you see where stat plots is, second, y equals is stat plot, and I'm going to arrow down or arrow up and hit enter. I'm going to make sure that the dot plot or the actual stat plot is on. And then I'm going to arrow down and go over to histogram, which it's already marked here, so that when I graph, it'll show it. However, I want you to understand something. I can't just hit graph because this is what happens. Oh, well, I've already set the window. The window's already set. I can change to make it look exactly like that. I'm going to make my Y minimum. I'm going to leave it there. My X minimum, 23, right? Because that's where it is, 28.8. Yeah, that's good. X scale, it all looks good. Although I think this right here, let's see what graph says here. Does it look exactly like this one? Yeah, it kind of does, doesn't it? Sure does. Well, let's make the minimum. If I want to look exactly like that, all I have to do is make the minimum 21 and the maximum 30. And I should have something similar to that now. Yep, see it? There you go. Looks exactly like it. Now, if I want to see what these values are, I can hit the number trace, or that trace right there, and it's going to start and it's going to move in increments of whatever my bin width is. So it also tells me how many there are. See, if you look at this, if I have 22 as my number, I have no values in that data set that have the number 22. In other words, none of the bags weigh 22 grams. And actually what this is, it's actually a bin width between 22 and 23. The minimum is 22 and less than 23. This one is, the minimum is 23 and less than 24, and so on. You can see how many are in each one when you look at N. N is the count of those values. As you can see, it matches exactly what we have. All right, so now we know how to do that. Let's continue on. Now we can actually do more with the calculator to create more precise numerical descriptions of the data. It is actually quicker and usually more accurate than computing by hand. Now, we're going to look for the mean, the standard deviation, the number of data values in the data set, the 5-number summary, and the numbers in the 5-number summary. Okay, so let's look at that. I'm going to use my calculator again. Pull it up. Now I see the values are already there. I apologize. It'd be easier if I did it the other way, but I can't pull this calculator out. Here, let's do that. So my values are still in there, stat, enter, and I'm looking at L1. L2 is a different data set. So I'm going to hit stat, and I'm going to go over to calc. I arrowed over 1, and this one variable stats is what I need. And there's a lot of information there. I'm going to go ahead and calculate it, and it gives me a list of things. All right, so X bar, also known as the mean, is 25.16. Remember we said that the average, which is what the mean is, was somewhere between 25 and 26. Now the standard deviation is a measure of the spread outness of the data set. So in other words, it gives you a value of about how far apart different values are from each other. This is 1.4628, okay? The closer to 1 you are, the least spread out it is. All right, N equals 25. N is actually what we call the count or the number of data values in the data set. That's it. There's 25 values, if you recall that. And the last 5 numbers are the actual, what we call the 5-number summary. Minimum, Q1, median, Q3, and maximum. And we'll talk about what those are in just a minute if we haven't already. So let's take a look at this. Mean is 25.16, spread outness 1.46, 25 data values. The 5-number summary is 23, 24, 25, 26, and 28. Well, what are the 5-number summaries? They represent the minimum data point, the first quartile, the median, the third quartile, and the maximum data point. Those 5 numbers separate the 4 quarters of the values. So 25% of every of the entire data set fits between those values. All right, sometimes it makes sense to analyze the proportion of a population that meets some criterion. This is another method for investigating whether or not the manufacturer is correct in claiming that the average weight of a bag of spuds is 28.3. So we're going to write a statement or hypothesis involving the proportion of bags. Proportion. This is not average mean or true mean weight. This is proportion. So how much of the bag weighs this much and how much of the bag weighs that much? So we expected 50% of all bags of chips weigh 28.3 grams or more. That's kind of an easy one to answer. And it helps us out a lot, unless the other bags weigh 0, which would not make any sense at all. More formally, the true proportion of bags that weigh at least 28.3 grams is 0.5. A proportion is a decimal or a fraction. And even more formally, we can make a list of those hypotheses using scientific notation, as they would use. The null hypothesis is that P is greater than or equal to 0.5, where P is the true proportion of bags that weigh at least 28.3 grams. And the alternate hypothesis is that P is less than 0.5. Note, this hypothesis actually refers to the median weight, not the mean, okay? 50% of the bags are more and 50% of the bags are less than 28.3 grams. Not the average. We're not talking about the average. The median is the number that falls right in the middle of the data set. So what proportion of the bags in your sample were 28.3 grams or more? Does this answer change your opinion about the distribution of weight? Why or why not? Okay, 100% of the bags in the sample weighed less than 20.3 grams. This may convince many that the manufacturer's claim is false. However, there's just not enough data values in this data set to make a claim. Like I said earlier, there is probably a means to say there needs to be a thorough investigation completed. All right, suppose instead that the weight of the chips in each Spud's bag is the following. All these values in this data set right here are now what we're talking about. We're going to produce a histogram and recompute the descriptive statistics for this set of data. And what do you notice? So this is what it looks like, but let's do it in the calculator just to be on the safe side. So I'm going to pull my little trusty calculator over there again. And it is right there. And stat enter. Notice that I have these values already listed in L2. So what I'll do is I'll go second stat plot, and I'm going to enter and turn off plot 1. And then I'm going to move up and over to plot 2. And notice it says L2. I'm going to change that. Oops, I cleared it. Shame on me. Here we go. We'll go to plot 2 this way. It still says L1. I need to change that to L2. Notice it's red, okay? So it's on. I'm going to turn it on, make sure it's on. But it says L1. I'm going to change that to L2. And how you do that is you hit second, and you come down here and you find L2, and you change it. And then you hit enter, enter, and you want to go and second quit. Now that you've got it all, stat enter. We're going to make a histogram of these values. So now we're going to go graph. Now notice I don't have all the values. It doesn't look anything like this one, does it? That's because the window is different. So I'm going to hit zoom and I'm going to hit 9. And that's going to put the values in. It still doesn't look like that. And there's a reason for it, and I'll show you what it is. If I go into window, look at my step. Okay? Now the minimums and the maximums are okay, but the step is an issue. I need to make that as close to 1 as possible. Okay? So I'm going to change that to 1, enter. And now when I graph it, uh-oh, I did something wrong. Number of data points needed for the calculation. Okay, let's go back to window. Hit enter first. Window, trace step 2. Okay. Let's zoom 9 again. Now I'm going to trace. Notice it's going by 2s. I'm going to change that to 1. So I'm going to go to trace step down here. And I'm going to change that to 1. See how that does it. Oh, well, what do you know? My window has really gotten large. Y max 9.36. No, X max. My X max is way too big. I only need to go to 35. So I'm going to change that. And we should have a good graph then. And graph, what did I do? Let's try this again. Y max is 36. Change this to 1. Change this to 1. enter. Oh, we'll graph now. Still have a window where we have this 154 as the maximum. So let's change that to 36. Graph again. And it doesn't like me today. It went back to that. See, I went to 36 and it changed this. One. Let's try to graph it now. See, it doesn't like that. I don't know why. Anyway, let's move on. You can see what it's supposed to look like. And I actually created this myself. I didn't find this. I put all the labels and everything in there. So I apologize for not having it and being able to do it. I'll do it in class if possible. So notice that we have a number of bags listed on the y-axis and the weight in grams of the bag of spud potato chips here. Now this kind of tells us there's really no outliers. 22 kind of a little bit, but not too far out. It is a little more widely distributed. Notice that the range is from 22 to 35 or 34. So we have a little bit bigger information here. It is fairly symmetric. The mean of the data, X bar, is 28.32, which is right here in the median. The standard deviation is 2.84. Notice that it's larger than the last one, which is 1 point something. It means it's much more spread out. There's still only 25 data values, but the 5-number summary is 22, 26.5, 28, 30.5, and 34. Minimum is 22, maximum is 34. The median is 28, 26.5 right in the center. 50% fall this way, or 25% fall on this side of 26.5. 25% fall between 26.5 and 28. 25% fall between 28 and 30.5, and then 25% fall between 30.5 and 34. So that's how the 5-number summary works out. And the average weight is comparable to the manufacturer's claim. And 64% of the bags weigh 28 grams or more. The data values, however, are much more spread out. The range is 12 from a low of 22 to a high of 34 grams. All right, so I'm going to launch you with this. That's not a whole lot of information, but it's enough to show you how to make at least a histogram. I showed you earlier in another lesson how to make a box and whiskers. I'll launch you with this. The media uses histograms often to describe the audience of large data sets that otherwise may not be understood. You can see this is the same launch we did in the last lesson. So there you go. There is a lesson in the Google Classroom. Please make sure you are an assignment. Please make sure you take care of it. I hope you watch this a couple times before you try to do that assignment. In the meantime, be blessed and be a blessing.